Assalamu alaikum everybody, I hope you're doing well. In today's video we're going to be factorizing expressions with 4 terms by grouping. So let's factorize the following expression. We have an expression with 4 terms, right? We have 3ab plus d plus 3ad plus b. Now the first thing I'm going to try to see is if there's any factor that is in common between all the terms. And here it doesn't look like it, right? It doesn't look like all of the terms share a common factor, right? You could say they share the common factor of 1. But that's not going to change anything. If I pull out a 1, the expression is just going to remain the same. So that's not going to be very useful. Is there anything other than 1? Well, I can't really see it. Okay, so maybe we can't factorize this expression entirely. But what if we look at the terms in this expression? Let's try to group the terms that share a common factor. Maybe then we could somehow get somewhere with this expression. Okay, so let's highlight 3ab here. And I want to see what other term in this expression shares a common factor with 3ab. The answer is not d, right? They share the factor of 1 maybe, but that's not going to change anything, so I'm not going to highlight d. What about 3ad? Yes, that's a potential pairing. I could pair maybe 3ab and 3ad, right? They both have a common factor, and that is 3a. Okay, what about b? B shares a common factor with 3ab as well, right? They both have the factor b, so I'm going to highlight b as well. So both of those terms are potential terms that I could pair with 3ab. But which one do I select? Now in this particular example, I actually can select both. Both of them work. I can pair either of them with 3ab. But as a general rule, I would say I want to make sure that whatever I pair with 3ab, the terms that will remain will also have a common factor. Meaning that, okay, let's look at what happens if we pair 3ab plus 3ad. Okay, notice that this is going to be my first group, and my second group automatically becomes b plus d. And unfortunately for us here, b plus d don't share a common factor other than 1, so I can't really pull something out here. And again, it works in this example. We can actually pair them that way. But in many other cases, that won't work, right? If we pair terms that don't have a common factor, we can't really factorize the entire thing. All right, so I want to get into the habit of pairing terms that share a common factor. All right, so let's say we pair 3ab with b. What happens then? Then what remains, this is going to be my first group, what remains is 3ad plus d. And I like that pairing because now this group has a common factor, and this group also has a common factor, right? Both of those terms, 3ad and d, share the factor d. Okay, so I can factor both groups, and let's do that here. So here I could pull out a b because both of them have a b, so pull out that b. And what remains is 3a over here. Okay, and then plus, what do I multiply b by to get b? Just 1. Okay, and then we have a plus. Here I could pull out a d, right? They both have a d, so I can pull that out. And what do I multiply d by to get 3ad? Just 3a. And plus d times what gives me d? D times 1 gives me d. Okay, and that's it. Now, this is looking good, right? We've been able to mix some terms together, group some terms together, and factorize the expression a little bit. So let's see if we can get even further with that. Notice now we have 2 terms, right? We have b times the quantity 3a plus 1. That's our first term. And our second term is d times the quantity 3a plus 1. So notice both terms have the factor 3a plus 1. And so we could pull that out, right? We could pull out the 3a plus 1 here. So 3a plus 1. Okay? And what's going to remain after we pull out the 3a plus 1 is here we're going to have a b. Plus, and here after we pull out the 3a plus 1, what remains is a d. And that's it. We have factorized this entire expression, right? So if it looks like we can't factorize an expression with 4 terms right off the bat, maybe we could group some terms together that share a common factor and then go from there, just as we did here. And as we can see, the result is really nice. It's really neat, right? We factorize this entire expression into this. Okay, so let's try another example. Let's factorize x squared plus 2x plus 5x plus 10. Okay, and the first thing I'm going to try to see is if there's a factor that is in common between all of the terms. And again, I don't see that here. And I can immediately say that because I don't see anything in common between x squared and 10 other than 1. All right, so I don't think I can pull out anything useful. So let's use the same technique we used in the previous example. Let's try to pair some terms that share a common factor and maybe go from there. All right, so I'm going to change color here, change colors, and I'm going to highlight the x squared. And I want to see what term in this expression, what other term shares a common factor with x squared? Well, 2x does, right? So I'm going to highlight 2x. They both share an x. 5x also does, right? X squared and 5x both share an x. And x squared obviously can be paired with 10a because they don't share a common factor. Okay, so I could pair x squared with either of those, but which one do I select? Now let's say I choose to pair x squared with 2x. So x squared plus 2x. So that's going to be my first group. That automatically means that my second group is 5x plus 10. Now, do I like that group? Well, yes, I do, right? Both of the terms in that group share a common factor, right? This is 5 times x, and 10 is 5 times 2. So they both share the common factor of 5. So, in fact, I can factorize both groups now, so that looks great. Okay, so in this group, I can pull out an x, right? X times what is x squared? Just x, right? And then plus x times what gives me 2x? Just 2. And then we have plus here. We could pull out the 5. All right, 5 times what gives me 5x? Just 5 times x, right? And then 5 times what is 10? It's just 2. And now notice we have 2 terms, and both terms share a common factor, right? We have this term over here, which has the factor x plus 2, and we have this other term here, which also has the factor x plus 2. So I can pull that factor out. Okay, which means that after I pull the x plus 2 out, here we're going to have an x, there's a plus, and here, after we pull out the x plus 2, there's a 5. And we're done. We factorize this expression, okay, into this. All right, so I hope that made sense. And by the way, I wanted to point out that we could have actually, so let me just remove this. We could have actually paired x squared with 5x here. All right, so x squared plus 5x. Because, again, they both have the factor x. And notice what's going to remain. After we pair those together, what remains is 2x plus 10. So that's my first group, and that's my second group. And I'm happy with my second group here as well because they both of the terms share a common factor, right? 2x and 10 share the factor 2. All right, so I could have done it both ways, and let me do this way really quickly. I could pull out an x here. What's going to remain is x plus 5. Plus, here I could pull out a 2. What's going to remain is x plus 5. Okay, and notice both terms now share the common factor x plus 5. So I can pull that out. Okay, and what remains here is x, and plus, and here what remains is a 2. Okay, so we get the exact same answer, just in a different order. But the order doesn't matter if you multiply, right? We can swap those around. Okay, so it works both ways in this case. All right, so sometimes you have to experiment, like what works best for you, and go with that. Okay, so in this case, we could have actually paired x squared with both terms. Okay, so let's try one more example now. Let's factorize 3x minus x plus x squared minus 3. Now I'm going to highlight x here, 3x, and I want to see what other term in this expression shares a common factor with 3x. And by the way, the first thing you want to see immediately is if there is a factor that is in common between all the terms, and here again it doesn't look like it because I don't see anything that's in common between x squared and negative 3. Okay, so that immediately tells me that maybe I should group some terms together. Okay, so let's see what I can group with 3x over here. Now, can I group 3x with negative x? Well, maybe, right? They both share a common factor. Or they both have x as a common factor. So I'm going to highlight x, or negative x. What about x squared? Can I group that with 3x? Well, yes, they both share a common factor, right? They both have x as a common factor, so I'm going to highlight x squared. What about negative 3? Negative 3 is also a term that shares a common factor with 3x, right? They both have 3 as a common factor. So that's pretty convenient. We can pretty much pair 3x with every other term in this expression. Now, which one of those do I select? Let's say I select the negative x. So I have 3x minus x. Okay, which means that this is going to be my first group, which means that my second group is x squared minus 3. Okay, and let me highlight that. Now notice I could pull out an x over here, which leaves me with, okay, x times what is 3x is 3, and x times what is negative x, just negative 1. Okay, but here I don't see anything I could pull out, right? So that's going to be a little inconvenient. I'm not sure what to do here. So maybe that's not the best pairing. Okay, that's why I said initially it's generally nice to pair terms that share a common factor. Okay, so let's see if I can pair 3x with something else. What about 3x with x squared? So 3x plus x squared, which means that my second group will be minus x minus 3. Now, am I happy with that grouping, with that pairing? Well, maybe, because they do share a common factor here other than 1. They share the common factor of negative 1. Right? This is negative 1 times x, and this is negative 1 times 3. So they both share negative 1 as a common factor. All right, so maybe that pairing is going to work. So let's try to factorize both groups. So in this group, I can pull out a 3. Oh, sorry, not a 3, my bad. I can pull out an x, right? And what's going to remain is 3 plus, and x times what is x squared? It's just x. Right? And then here, we could pull out a negative 1. Now, negative 1 times what gives me negative x? Just x. And negative 1 times what is negative 3? Just positive 3. And this is really nice, right? Because notice now we have two terms that share a common factor. And it might not be, immediately noticeable here, but this 3 plus x can be written as x plus 3. And let's do that here. Let's not get this to be confusing. So let's just actually remove that. And let's just rearrange that 3 plus x to be x plus 3. So now we have two things that look exactly the same. Okay, so now we can highlight that x plus 3 as a common factor, and we can pull it out. So x plus 3. All right, and let's see what remains. So here, we pull out the x plus 3, what remains is an x. And here, what remains is a negative 1, and that's it. We have factorized this entire expression. So that's pretty good, right? So that pairing actually worked. Okay, so you can, If something doesn't work, I encourage you to experiment. But as a general advice, I would just tell you to pair terms that share a common factor. Okay? And another way we could have done that, by the way, is, let me remove that again. is we could have paired 3x with negative 3. So let's see what happens if we do that. 3x minus 3. Which means that my second group will be x squared minus x. Right? So first group here and second group here. So let's factorize both groups. This group I can pull out a 3. And what remains inside is x minus 1. And here I could pull out an x. So x times what is x squared is just x. And here just minus 1. Okay, and notice now we have two terms that share a common factor, x minus 1 and x minus 1. So I could pull that out. And what remains is a 3 plus x, which is exactly what we got in the previous answer. It's just that the order is a little bit jumbled up. And by the way, again, the 3 plus x can be written as x plus 3. And let me actually just do that here. So this can just be written as x plus 3. And in the previous answer, we got x plus 3 times x minus 1. But again, the order in which you multiply doesn't matter. So we could have the order swapped. Okay? So again, guys, if you look at an expression with 4 terms and you can't see anything to factor, try to group terms that share a common factor and go from there. See what happens. Okay? And hopefully you can factor an expression with 4 terms into something that's really neat and nice, like that over here. Okay, so that's it, guys. I hope you found the video simple. If you have any questions, please let me know in the comment section below. And that's it. And I will see you next time.